The acceleration of an object in meters per second squared is given by the function acceleration is equal to 7 times sine t. The initial velocity is given as -8 meters per second, and when we enter our answers, we're going to round our answers to 4 decimal places. The first part asks us to find the equation for the velocity of the object. Now, because we know that the acceleration is the derivative of the velocity, we're going to work backwards and integrate to find the velocity. So we're going to integrate the acceleration. So we're going to integrate 7 sine t dt is equal to, and then we get -7 cosine t plus our constant. And then we use the initial value to find our constant. Our initial value is -8. So I'm going to set up this equation so that I have -8 is equal to negative cosine 0 plus our constant. And when I solve for our constant, we get -1. So our velocity equation in total should be negative cosine t minus 1. Now, for parts P, B, and C, we need to find the object's displacement and the total distance. The displacement is really another way of saying the net distance. So we're going to take into consideration the negatives and the positives. When we look at the graph of negative cosine t, we get this kind of a shape, and we're only looking at it from 0 to 3. Area below the graph, I'm going to call that A1, and that should be negative because it's below. Now, when we look at the area above the x-axis between the curve, that's going to be, we'll call that area 2, and that should be a positive area. Now, we can figure out what those areas are by finding that intersection right here with the x-axis, or you can use the 0 function on your calculator. And you'll find that that value where it intersects with the x-axis is 1.714139. So what you're going to do is to find the area below the x-axis, you are going to integrate from 0 to 1.714139. And that should give you this area right here, which we anticipated should be negative because it's below the x-axis. Now, to find the area under the graph above the x-axis, we want to integrate from 1.714139 up to 3. That will give us our area 2, in which we would get a positive area, which we should get is 4.6545071. Now, to find the net area, which is part B, the object's displacement, you want to just add these values together. That is where we take into consideration the negatives and the positives. For the total area, we just want the absolute value. We don't care about which direction it's going. We want to know the total distance traveled, no matter which direction it's in. So we don't want to take the negatives and positives into consideration here. We just want to add the two distances together. So in this case, I would add 4.6545071 plus 8.642347. So when I take the negatives and positives into consideration, that would be my displacement in part B. That would be negative 3.98784, which means it traveled more in the negative direction than in the positive direction. When I look at the total distance traveled, which is the total area, okay, I don't care about the negatives and positives. I just want to add up the absolute values of those. So I would get 13.29685. And then this would represent the net area, and this is the total area of the graph. But in terms of distance, this would be the displacement, and this would be the total distance traveled. That would be our answer to part C. And then, of course, you want to make sure that you round it to the appropriate number of decimal places.